So the Algebra 2 Practice Final Even Solutions. Number 2. 8 minus 4 plus 2x is greater than 8x minus 8 times 4 minus x. First thing I'm going to do is distribute here. We're looking at 8 minus 4 minus 2x, 8x minus 32 plus 8x. Combining like terms over here, plus 4, 16x, combining like terms over here, minus 32. I'm going to subtract 16x to both sides, subtract 4x to both sides, and we're looking at negative 18. X is greater than negative 36 divided by negative 18, and we're looking at x is less than, because I got to divide it by negative 2. Number 4, the absolute value of 5x minus 8 equals 28. Remember, when it comes to absolute value, you have to split it up. Alright, one's positive, one's negative. Add 8 to both sides. 5x is equal to 36 divided by 5. And over here, add 8 to both sides. 5x equals negative 20 divided by 5, and x equals negative 4. Number 6, very similar looking question, but with an inequality, and when you split this one up, when you do the negative one, you have to switch the inequality sign. Subtract 4 to both sides, divide by 8, and x equals 13 over 4. Sorry, x is less than 13 over 4. Subtract 4 to both sides on this one, and get 8x is greater than negative 34 divided by 8, and x is greater than negative 17 over 4. Okay, now you got to, they want this as a conjunction, looks like. So if I was to kind of graph this, okay, the x is greater than that going this way, and it's less than that going this way. So you can kind of, I'll squeeze this here in the corner, you put the x in the middle, and these inequalities need to be facing the same direction, and that's your actual answer right there. Okay. Number 8.
Attention students,
So that's in and out, and
took the ASVAB exam last month, please report to the library to pick up your scores and attend the interpretation meeting. Again, students, if you took the ASVAB exam last month, please report to the library to pick up your scores and attend the interpretation meeting taking place now in the library. Thank you.
Now looking at this one, number 8, it says basically got 850 people attended the play. So, and there are adult tickets and student tickets. So here's adults plus students equals 850. Then the next one's about money. And it says if you multiply 150 times the amount of students and $2 times the number of adults, it adds up to 1650. Just to rewrite this a little bit, I should probably line the correct variables up. Okay. So what I'm going to do here is multiply this top one by negative 2. I'm just going to kind of rewrite this underneath. and then multiplying that out should be 1700. Sounds right. Negative 1700. Rewrite. I'm just going to rewrite this bottom one. Okay. So this goes away. That was a point. I get negative 0.5 equals negative 50 s. Divide by negative 0.5, and that should be s equals 100. That's the number of students. They don't want students. I think the question they actually asked for adults, so be careful with that. And so A would have to be 750, right? Because remember, they add up to 850. So I can assume that A is 750. 10. It's kind of hard to see these graphs. I'm just going to graph number 10. The first thing I want to do is solve for y. So I'll subtract 3x to both sides. I'm looking at 2y is less than negative 3x plus 6 divided by 2. And y is less than negative 3 halves x plus 3. So when I graph this, okay, I'm going to use y equals mx plus b. It is an inequality, so this is going to be a solid line because I have a line underneath here. So I'm looking at 1, 2, positive 3 is my y-intercept. I'm going to go down 3 and over 2 spaces. Okay, it's a solid line because it's or equals 2. Okay, and then it says the y's are less than. Okay, I can plug in the point 0, 0, and if I plug in 0, it's actually a true point, so I'm going to shade underneath the line. Okay. Shade underneath the line. Number 12, same thing. I'm just going to go ahead and graph this one. The diagram is harder to see because of the copies, but the first one is already set equal to y. Okay, so that one's good to go. Over the second one, I'm going to subtract x to both sides, so I get y is greater than negative x plus 3. Okay, so I'm going to put a box, or these are the ones that I'm actually going to graph. Okay, and we're going to graph one at a time. Okay, so graphing this, we're going to get 1, 2, 3, 4, up to over 1. It's right there, and this is a solid line also. Okay, and I'm going to shade below this one because the y's are less than, so I would shade down here. This one over here, I start at positive 3. I go down 1 over 1. This is also a solid line. And I shade above it because the y's are greater than. So that would be this way. And you can see my answer is in this region right there. 14. It's a 3-variable system. Okay, and so if you remember this, if you look at it, none of them really match. So you got to put your zeros in. So I'm going to rewrite this as 2x plus 3y plus 2z equals 13. I'm going to write this as 0x plus 2y plus z equals 1, and 0x plus 3y plus 2z. And kind of looking now that I wrote it, I realized I didn't really need to do that because these two are kind of already set up. So I'm just going to use these two as a 2-variable system. Okay, so I'm going to multiply this top one by negative 2 and get rid of these z's. So I'm basically looking at negative 4y minus 2z equals negative 2 all over 3y plus 2z equals 3. And then those cross off and I get negative y equals positive 1. Divide both sides and I get y equals negative 1. Now I'm going to take that, plug it back in. I'll plug it into this one. So I'm kind of looking at 2 times negative 1 plus z equals 1. Gives me negative 2 plus z equals 1. Add that to both sides. Z equals 3. So now that I got those, I'm going to plug it into this top one. I don't know x. I'm going to say 2x plus 3 times negative 1 plus 2 times 3 equals 13. 2x, this is going to be negative 3 and positive 6. So it gives me positive 3. Subtract 3 to both sides. I get 10. Divide by 2, and x equals 5. So my answer is the coordinate point 5, negative 1, 3. Okay. That's my actual answer right there. So since I saw these two were the same variables, I just treat that like a two-variable system. Take the answers, plug it back into the original one. 16. Now we're getting into some factoring. Okay. 16a to the 4th minus 81b to the 4th. Okay. And this is the difference of squares, because 1681 and anything with an even power. So this is going to be 4a squared minus 9b squared times 4a squared plus 9b squared. Now this one again is also a difference of squares, so that's 2a minus 3b plus 2a plus 3b. This one is not because it's a plus, so I just rewrite that one. 18. They want you to factor completely. So same thing, like I always look for a GCF first. So I'm going to take out a GCF. X minus 4, x plus 4, and there you go. 20. 8a to the 3rd minus 8ab squared. So my GCF here is 8a, using with a minus b squared. Okay, and there's nothing I can do with that. If I look at, oh sorry, that's an a squared. So actually there is more that I can do with that. So I'm looking at a difference of squares in there. A minus b. 22. Oh, sorry, that was actually 19. Here's 20. 20's not that bad. A lot of people get freaked out over this, but just like you got this a squared, if I was to set this up using guess or check, I would know that there's an a there and there's an a there, right? Well, that's the same thing here with this b. There's just a b there. So now pretend the b's aren't even there. If I take them out, I can pretend they're not even there. And I'm going to try 2 and 2 and 5 and 5. I know it's a sum of cubes. That gives me, if I multiply these two, it gives me 10. If I multiply those two, it gives me 10. So the answer is minus and minus. So you could rewrite that as squared. Okay. 22. We're looking at x times a minus b plus 2 times a minus b. Now the GCF here is actually the whole binomial a minus b, so that comes out, and I'm left with x plus 2. Let's go one more on this video, number 24. 24 is what's equivalent here, and if you look at this, we've seen a lot of these lately. This is a sum of cubes, thinking of this as that. So I'm going to say same, opposite, always positive. Looking at g2, g squared times 2 times g. Remember, our a's and b's here are not 8, it's a 2, and then 4.